NASA is sending two tiny spacecraft to Mars. But here's the twist. They rehitching a ride on Blue Origin's New Glenn, an improved rocket that's only flown once. Why would NASA risk a critical mission on something so uncertain? And what secrets do these twin probes, named Blue and Gold, hope to uncover about Mars' lost atmosphere? This story isn't about going to Mars. It's about unlocking a cosmic mystery using bold science, smart engineering, and one seriously risky ride. Let's unravel why this changes everything. The ESCAPADE mission, short for Escape and Plasma Acceleration and Dynamics Explorers, is NASA's first interplanetary dual satellite mission designed to map how Mars loses its atmosphere to space. And it's doing that with not one, but two nearly identical spacecraft, Blue and Gold. These small but powerful probes, developed by the Space Sciences Laboratory at UC Berkeley and built by Rocket Lab, are about the size of a mini fridge and weigh less than 200 kilograms each. Despite their size, they repacked with science instruments specifically designed to investigate how solar wind interacts with Mars' magnetosphere. Each spacecraft carries a magnetometer, electrostatic analyzer, and linear probe. These tools will measure the strength and structure of magnetic fields, analyze the energy and composition of charged particles, and detect plasma density and temperature. Together, they'll build a three-dimensional map of how particles flow and escape from Mars into space. So why two spacecraft? Mars has a patchy, localized magnetic field, unlike Earth's global one. This makes it impossible for a single orbiter to capture the full picture of its space environment. With two synchronized orbiters flying in formation, ESCAPADE can observe different parts of Mars' magnetosphere at the same time. That allows scientists to understand how solar events, like flares or coronal mass ejections, create ripple effects across the Martian environment. But it's not just about Mars. By understanding how a weak or spotty magnetic field affects atmospheric loss, scientists gain insight into why some planets retain their atmospheres and others don't. It informs how we study exoplanets, especially those in habitable zones, and helps us predict how Earth might behave in the distant future. ESCAPADE's science mission is clear. Trace the invisible pathways through which Mars is bleeding into space. If successful, these twin probes could reshape our understanding of planetary evolution, magnetic shielding, and atmospheric retention. But for all this to happen, NASA had to find a rocket, and what they chose surprised everyone. NASA could have played it safe. It could have chosen a Falcon 9 or an Atlas V. Instead, it chose Blue Origin's New Glenn, a rocket that had never flown when the contract was awarded. ESCAPADE was initially scheduled to launch in 2024 on New Glenn's maiden flight. But by mid-2024, Blue Origin announced a delay. NASA made a tough call. It pulled ESCAPADE off the first mission and reassigned it to New Glenn's second flight, now expected in late 2025. Why would NASA bet an interplanetary science mission on a rocket still finding its footing? The answer lies in ESCAPADE's classification. It's part of NASA's Simplex program, short for Small Innovative Missions for Planetary Exploration. These missions are designed to be low-cost, high-reward experiments. ESCAPADE's budget is relatively modest, estimated at around $79 million, a fraction of what flagship planetary missions cost. That flexibility allows NASA to take calculated risks. In 2023, NASA signed a $20 million launch contract with Blue Origin under the Venture-class Acquisition of Dedicated and Rideshare (VADR) program. This initiative is all about fostering competition and building trust with new commercial launch providers. By choosing New Glenn, NASA isn't just sending a probe to Mars. It's giving a green light to a major new player in the launch market. But make no mistake, the risks are real. New Glenn is a gigantic two-stage rocket with a reusable first stage powered by 7B4 engines, the same ones that power ULA's Vulcan rocket. While powerful on paper, New Glenn's first flight only occurred in early 2025, and although it reached orbit, its booster failed to land. That's why ESCAPADE was pushed to the second flight, dubbed NG-2, where Blue Origin hopes to demonstrate a fully successful launch and recovery. Also on board NG-2 is a Viasat technology demo payload under NASA's Communications Services Project, which seeks to test commercial alternatives to NASA's Deep Space Network. So what's at stake? A science mission to Mars, and the future credibility of Blue Origin's flagship rocket. For ESCAPADE, this launch is more than a ride to Mars. It's a statement about the future of space access. Now that we know how ESCAPADE is launching, let us see how it plans to actually get to Mars and what its timing means for planetary science. Reaching Mars is all about timing, and ESCAPADE's journey is anything but typical. Originally planned to launch in October 2024, ESCAPADE missed that direct Mars window due to New Glen's delays. So NASA developed a new, more complex trajectory. Now scheduled for late 2025, ESCAPADE will not head directly to Mars. Once the alignment is just right, they'll perform a gravity assist maneuver by swinging back around Earth, using its gravity to slingshot toward the red planet. This technique is a clever workaround for missing the original launch window and saves fuel while giving the probes a unique observational vantage point along the way. If all goes to plan, ESCAPADE will arrive at Mars in September 2027. Upon arrival, the spacecraft will enter a highly elliptical orbit before slowly adjusting over several months into their designated science orbits. These orbits will allow them to sweep through Mars' magnetosphere repeatedly, measuring how it changes over time and space. What makes this journey special isn't just the destination, it's the strategy. By parking at L1 and returning for a slingshot, ESCAPADE demonstrates NASA's ability to flexibly re-engineer missions in the face of launch delays. It also turns what could have been dead time into an opportunity. The spacecraft will begin collecting valuable solar wind data even before leaving Earth's neighborhood. This trajectory ensures ESCAPADE won't miss the next Mars window in December 2026, positioning it perfectly for a low-energy transfer. And once there, its 11-month cruise phase followed by 2 years of science operations could provide unprecedented insights into how planetary atmospheres are stripped away. The choreography is precise, the margin for error slim. But if successful, ESCAPADE's cosmic dance will prove that agility, timing, and innovation can deliver breakthrough science, even when the launch plan changes completely. And all of it builds toward a deeper question. How did Mars become so barren? And could it happen to Earth too? ESCAPADE isn't just a science mission. It's a bold experiment in trust, timing, and technology. 2 tiny spacecraft are being launched on an unproven rocket, flying a non-traditional route, and taking on one of the biggest mysteries in planetary science: how a planet loses its atmosphere. If ESCAPADE succeeds, it will rewrite what we know about Mars, test the future of commercial deep space launches, and open new doors for low-cost planetary exploration. The risks are real, but so is the potential reward. Thanks for watching. Don't forget to like, share, and subscribe, and follow us for the next deep space breakthrough.